and welcome to this video. In this video we are going to be finally looking at the scoring parameter, which we only touched the surface of in a few videos back. So that's what we're going to be learning about today. If you would like to catch up on any metrics or any ways to evaluate a machine learning model before this, so you're ready, then feel free to do that. You can watch my previous videos, or what you can do is you can go to this website. I'm going to put the link below, and what I'm going to do is if you want to search it up instead, what you can do is you can just search up evaluating a model, Scikit-Learn. That's what I typed in. And what you want to do is you want to go to metrics and scoring. And basically you have all the three types of evaluation. And you have the Scikit-Learn metrics. That's what we've been doing most recently. We've been looking at different metrics, and yeah, so these are some, we've only done a few metrics from here, so please watch your previous videos if you want a bit more of a clear understanding of these metrics. But for now, we're just going to look at the scoring parameter today. So let's go back to, So what we're going to do is we are going to just add a heading. So enter. So 4.4 finally using the scoring parameter. Okay, caps there. And then we'll just press Shift Enter. We have our mark down here. So basically, if I go back to the documentation I just showed you, so metrics and scoring, quantifying the quality of predictions, what you will see is that we have the scoring parameter right here. And basically this includes cross-validation, so we're going to be using cross-validation. I have a video in that. I'll put a reference link just above. And basically we're going to be using CLFScore to use the scoring parameter, if that makes sense. But you'll see in a second what I mean by that. So basically we're going to have to import cross-val score for this, so cross-validation, and then it'll be easier. So what we're going to do is I'm going to say from Scikit-Learn dot model selection import cross-val score, so cross-validation scoring. And then again, what I'm going to do is I'm just going to import the model we're going to be using. So I'm going to import one of the models we're going to be using today. And we're going to be using a classification model for this part. So ensemble. So from Scikit-Learn.ensemble, import random forest classifier. So if you do not know what this is yet, you might want to learn what that is first. Otherwise, it's going to be quite difficult to know what we're doing. So as usual, we're going to create a random seed, np.random.seed, 42. We always use that number. So x is equal to heart disease dot drop. We're going to drop the target column. Axis is equal to 1. Y, hang on. Y is just the target column. So we're just going to simply index that from there. And then we can create, we actually don't need to create X, Y. We don't need to create the training and test sets because when we use CLFScore, it does it automatically for you. So we don't need to do that. So we're going to leave that for now. I'm just going to go CLF is equal to random forest classifier brackets. We don't need to fit it either, which is a great relief. So if you're using cross validation, then you'll be really happy and stuff because you won't need to write too much code. Okay, so what we're going to do is we're going to just set the random seed again, so we get nice equal values. So np.random.seed cv ac, so that's cross validation accuracy. So we're going to be looking at the first scoring parameter. So I'm going to go cross val score. We're going to pass in the model x, y, cv is equal to 5. So that will give us 5 values in return. Scoring is equal to none. So you might already know why I set scoring is equal to none. So basically, if we look at CLF.score, we're not going to run it, but if we press Shift Tab, so this is a classification model, and it says return the mean accuracy on the given test data and labels. So this is like the default scoring parameter, and that's what CBAC means. So AC is basically our default scoring parameter. That's why we set scoring to none. You don't need to set it to none because it will be set to none by default, but I was just going to show you why I set it to none. So we obviously got 5 decimal values. So basically, if you want to look at if you want to just look at one value, all you need to do is just calculate the mean of all of this. Okay, so I'm just gonna go cross-validated accuracy. So this is our cross-validated accuracy. So we're gonna print. We're gonna use an F string for this. So F string. So the cross-validated accuracy is colon. We're gonna put in our curly braces here. np.mean cvac or accuracy, whatever you want to say. And then what we're going to do next after that is we're gonna multiply that by 100. So I'm gonna actually view this as a percentage. So that's why I'm gonna multiply it by 100. And then we're gonna put 0.2 f. So it'll give us 2 decimal places after that. Even if you only need to add 1 decimal place, but it's going to give us 2 decimal places after that, and then we're going to put in the percentage sign, and that should work. Okay, so the overall cross-validated accuracy is 82.48%. So not too bad for our model, but we could do better. But first we're looking at evaluating, obviously not improving. So we're just going to be looking at a scoring parameter now. So basically what we can do is, let's see, if we set scoring to accuracy, will it give the same result? Will it give the same result as this? It should. So let's just see if it does. So we're going to go CVAC. CVAC is equal to cross-val score. We obviously need to pass in CLF x, y, CV is equal to 5. And then we're going to put scoring is equal to accuracy. And then we're going to go on a new line, and we're going to look at the mean. So np.mean, and then all we need to do now, actually, what we can just do is, instead of just putting the mean, we can express this a bit more visually. So I'm just going to copy that line and paste that there. So let's run this. Oh, so it's giving us a different accuracy. So that's because we need to use a random seed. So np.random.seed. Otherwise, we're using a random seed to keep our things unique. Because if we don't use a random seed, results may come differently. So there we go. We have exactly the same accuracy because the default scoring parameter is accuracy. So now you can actually use different scoring parameters. Obviously, why not? So the first one is we're going to take some of these from a previous metric we looked at, and that was classification report. So you can obviously only use it with a classification model. We looked at that before. I have a video on that. I'll be sure to put the link in this video. So we're gonna take specific metrics from our classification report and see if they work. So precision. So we get first one. We're gonna look at precision. So CV underscore precision is equal to cross val score. Same again. We just pass in what we passed in before. But instead, we're going to put scoring is equal to precision. And then just to shorten things up, we're not going to put this in there again. What we're just going to do is simple as that. We're just going to do np.mean. Whoops, typo there. np.mean. And then we're just going to pass in CV precision. So we got a slightly different value to than before. We got 0.8085601, blah blah blah. That's actually quite similar to what we got before without the random seed. So precision is actually quite similar to accuracy, but it has its differences. So the next metric we're going to look at is recall. So again, we're just gonna do all the simple stuff again. So CV recall. There's so many typos here. Cross val score. I've just pressed tab. It might not appear, so I'm just gonna type it in. Cross val score. And usually, we'll just do the usual. We're just gonna type in CLF XY CV is equal to 5. And then we're going to put scoring is equal to recall. So there's no code names for these metrics or anything. You can just type the thing in, and then we'll be fine. So np.mean and then CV recall. Okay, so here we got a bunch of 848484s, but we also get, so there's like a pattern here, 842, 42424242. Okay, so there's some sort of pattern going on here, but we won't worry about that. So the last metric we're going to look at is F1. So CV F1. I actually might put F1 up here just as a comment. F1. CV F1 is equal to cross val score. And then we'll type in the use CLF XY CV is equal to 5, and then scoring is equal to F1. And then we'll just put in the mean again. Okay, so all of these give us different values because obviously they're different metrics. So if you use a different metric, you're going to obviously get a different value. So So you might be wondering, we've looked at classification models. How about regression models? So we're just gonna put a little question here. How about our regression model? Okay, so that's probably what you're thinking. You might not be thinking that, but let's just say it's good to keep that question in mind. So we're just gonna get a little bit more practice. We're going to just go from Scikit-Learn dot model selection, import cross val score, and then from Scikit-Learn dot ensemble, import random forest regressor. Okay, so we're just gonna set a random seed as 42. X is equal to Boston df dot drop. Okay, so we're just going to fix these typos here. Axis is equal to 1, and then it's much easier on Y. We're just gonna go, hang on, I'm just gonna check if my X is capital. What? There we go. There we go. I don't know what just happened there. So Y is equal to Boston df, and then just simply index target out of there. And then we'll just create a model, no fitting or anything. So model is equal to random forest regressor. So now before we go on to look at the different other scoring parameters, regression models have a different scoring parameter to classification. So they have a different default scoring parameter. So here we have our default scoring parameter for a regression model is R squared. We've looked at that before. It's just a default scoring parameter. So it's just to return the coefficient of determination. You can call it that as well. So we'll just take that away now. So np dot random dot seed 42 to keep our results balanced. So I'm gonna go CV R2 is equal to cross val score model XY CV is equal to 5 and scoring is equal to none. Of course, you could just put R2, but we're just gonna do this first. NP dot, so R2, R squared. Pronounce it R squared, sorry. So CV R squared. So that is what we would usually get. Our regression model is not very good right now, but that is what you would usually get if you use model.score. Actually, not if you use model.score, if this is just the mean of cross-validation. Of course, we could have gotten better values in our array, but this is just the mean, so don't worry about it too much. So again, I'm going to set a random seed. And again, we're going to put R2, and I'm not going to put the mean thing this time. So CV R squared again is cross val score. It's good practice to keep on typing like this. And always make sure to put your model first. X, Y, CV is equal to 5. Scoring is equal to R squared. And then we're just going to do CV R squared. We've got all 5 values this time. Of course, there's some good ones here. These ones over here are so bad. So some parts of our array, our models struggled on a bit too much. Okay, so that's why we got quite a low value over here, but overall it's just fine. So there's only 2 evaluation metrics we need to look at for 2 more we need to look at other than R squared. So we'll just do those quickly and then we'll be finished. So first one we're going to look at is mean absolute error. This one's pretty easy to understand. So CV.MAE for short is equal to cross val score model x y CV is equal to 5 and scoring is equal to mean absolute error. Okay, and then you're going to go mp.mean cv.mae. Oh, actually, we don't need to search up the mean again. Just cv.mae. Oh, it's giving us a key error. So what's it saying? Mean absolute error is not a valid scoring value. How can that be? Okay, so what we can do is we can actually check the documentation if we have any problems. So I'm just gonna go to the documentation. So let's go down a bit. Okay, regression. Let's search for mean absolute error. No, but the closest one here is neg mean absolute error. And here it says metrics.mean absolute error. So that could be the one we have to type in instead, because we have imported it from here. So maybe we have to type in neg mean absolute error instead. Okay? So this is how you should do things. You should be solving them as you go. Go to documentation if in doubt. And you'll be able to fix it very quickly. So neg. Oh yes, so that has actually given us negative values and no errors. So how could this be? Again, we're just gonna go on to the documentation here. So let's just go up. So here we have common case predefined values. So for the most common use cases, you can designate a score object with the scoring parameter. Okay, so it's talking about the scoring parameter here. The table below shows all the possible values, blah blah blah. All scorer objects follow the convention that higher return values are better than lower return values. Thus, metrics which measure the distance between the model and the data, like metrics mean squared error, are available as neg mean squared error, which return the negated value of the metric. So basically, for mean absolute error and mean squared error, it's obviously going to return the negative value, and I guess it shows you how bad it is. So basically, I don't think our model still needs to improve a bit, because it's got -2, -3, so on and so forth. So we've looked at mean absolute error. Why not just go and look at mean squared error? So let's just do that quickly. Mean squared error. So CVMSC is equal to cross val score model xy CV is equal to 5, and scoring is equal to neg mean squared error. Okay. And then np.mean CVMSE. Okay, so we got -21.128 blah blah blah. Maybe if we just take away the np.mean for now, I'm just going to comment that out so we can come back to it later. So we're just going to type in VMSC. Okay, so we got negative values here. So I'm just gonna take that away now. Control /. Okay, so basically here we got minus 21 point blah blah blah. Last time we looked at mean squared error, we got, okay, hang on, I'm just gonna fix something quickly. Actually, never mind. So last time we got mean squared error, we got something like 9 point blah 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 blah, and here we got 21. So maybe that could be related here. So yeah, so I guess that's the end of this video. We finally looked at the scoring parameter. Next, we are going to be looking at our final our final evaluation thing, and that is problem-specific metric functions. So you're going to be looking a bit more at them. Although we have looked at classification and regression ones, we're going to be looking a bit more at them. So please look out for the next video. If you like this video, please like and subscribe. That would really help. And if you have any doubts, please comment them in the comment section below, and I will try my best to answer them. And yeah, I guess that's the end of this video. Bye.